So this is equal to 2 cos squared 2 cos squared x. So this is yes, yes. Ah, let me share the screen. Thank you. So we continue now. So this is a non-homogeneous equation, and we have this is the function g of x. So we have to find firstly the homogeneous solution, then we look for the particular solution. We begin by the characteristic equation. So it is k squared plus 16 is equal to 0. Remember, this is yeah, yeah, so this is double prime, and you have 0 times y prime. So we have 1 times k squared plus 0 times k plus 16. Don't forget, in the exam many of you put 16k. Remember, this we don't have here y prime, so it is only 16. Okay, let me delete this. So this is actually, so what this gives you, k squared is equal to minus 4 squared, so eventually k is equal to plus minus 2e, which is purely imaginary. So the homogeneous equation, homogeneous solution YH is C1 times cosine. Remember, it is C1, so this is of type, this is alpha plus b, and here alpha is equal to 0 and b is equal to 2. Okay, so it is exponential 0 x times c1 cosine beta x plus the remaining. You see the preceding the precedent lecture. So it is 2x plus c2 times sine 2x. Okay, so this is the homogeneous part.
Excuse me.
Yes.
I wanted to ask about the square root part. The square root of square.
Ah, yes, 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 I did a mistake. It is minus plus 4i. Here we should have, since this is 4 squared, the square root would be here 4. So thank you, Rayla. Plus minus 4i. So here we have, so here we should have, sorry. So let me correct this. We have here 4x and here 4x. Thank you, Rayla. Is there any other mistakes or observations? So we continue. Next thing, let's guess the solution. So here uh, so let's guess the solution. How to guess it? Here we have 2 cos squared. x. But if you try to how to do this, to get rid of the cos squared and simply write it as a linear combination of trigonometric functions. So here what we get, cos, so here we have 2 cos squared x. So how to rewrite this? This is actually equals to, remember that, how to write this. So we have cos a plus b is equal to cos a times cos b minus sine a times sine b, and sine a plus b is equal to something like this, cos a times sine b plus cos b times sine a. So how now to linearize this? So if we have cos x plus x, we should get cos squared x minus sine squared x, and in this case we have cos squared x minus the sine is 1 minus cos squared x, so finally you get 2 cos squared x minus 1, which is equal to cos 2x. So finally this guy here would be, you will get 2 cos squared x is actually equals cos 2x plus 1. Okay, so we will use this in our equation. Okay, so Rayla, does this law is correct? I sometimes forget the rules. Is cos a plus b is actually equals to cos a times cos b minus sine a sine b.
Yes, that's true.
So now we replace it. So this equation is actually, let me rewrite it down here. So let's take this part, copy this part here, copy. Now we get down. So paste. So this guy would be equals to, so this is equals to cos 2x plus 1. Okay, so we have a trigonometric function plus a constant. So let's try to guess what is yp. Let's put something like this. Let's put something a times, remember, here the 2 is not root. Remember that our roots k are actually plus minus 4e. Okay, so 2 here is not a root, so we guess yp is only a times cos 2x plus another constant b times, let me write it down, let's delete this. So plus b sine 2x plus we have here 1 plus another constant c. Let's guess the particular part like this. Here we don't, since this is not a root, we do not multiply it by exponential, something like k exponential. We simply write it like this. Okay, so let's find A, B, and C. So how to do it? Do you have any idea? So let's replace yp into our equation. So yp double prime plus 16 yp. So let's take the second derivative of this. The derivative of c is equal to 0, so we derive the first time cosine is equal to minus 2 sine 2x. Then we repeat again, it will be uh, so here the first derivative, so this is yp, so we compute, let me delete this, we compute, so this is y, so y prime, it would be the derivative of cos would be minus sin, so minus 2a sine 2x plus the derivative of sine is cosine plus 2b sine 2x. The derivative of c is equal to 0. Now yp double prime. So minus 2 times 2, it is minus 4a cos x squared plus sine, here I did mistake. Sine would turn to be, here we have cos 2x. So it would become cos, again it will be minus sine. So let's delete this plus, it would be minus 4b, and we return again to sine 2x. Now we substitute in our equation. So what you get is yp double prime plus 16 yp. So it is minus 4a cos 2x minus 4b sine 2x plus 16 times a cos 2x plus b sine 2x. So if you continue, what you get, let's collect these together. So we get minus 4a and plus 16a. It would be 12a cosine 2x. Now minus 4b plus 16b. It would be also equals to plus 12b sine 2x. Okay. And remember that this is actually equals, I did forget something. Yp, we have also the constant c. So a, b, and plus c. So plus 16c. Okay. Now let's, so this equals should satisfy this part. 2 cos squared x, which is equal to cos 2x plus 1. So this is equal to 2 cos squared x, which is equals to cos sine 2x plus 1. So now by identification we must get the following system of equations. So 12a should be equal to this guy. So it is 1. Now do we have sine here? So what we put? So 12, yes, 12b is equal to 0. Now what remains is 16c. 16c is equal to what? What? So a is equal to 1 over 12, b is equal to 0, and c is equal to 1 over 16. Okay, so that's it. We found the particular solution. So yp is equal to 1 over 12 cosine to x plus 0 sine to x plus c, which is 1 over 16. So the final answer is 1 over 12. Remember, this is only the particular solution. We didn't yet write the general solution. So now the general solution is yg is equal to the homogeneous solution plus the particular solution. So this yg is equal to c1 cosine, what is our roots, 4x plus c2 sine 4x plus 1 over 12 cosine 2x plus 1 over 16. So this is the final answer. Okay, is it clear for you? Okay, the particular solution plus the homogeneous solution. Now we continue with the next problem. Is there any question before going to the next problem? This problem we should use here the variation of parameters. Here the things are going to be a little messy, not like the first ones. Okay, so now the variation of parameters, and we have problem 7. Mathematics is about solving problems, and if we don't have problems we create them. So we have y double prime plus y is equal to, do you see this color? Do I continue with it or I change the color? Is equal to 1 over cos squared x, and we don't have